Hi everyone. A very warm welcome to today's webinar on enhancing industrial efficiency with cutting-edge technologies. It's a pleasure to have you all here for this very exciting session. The topic of today's webinar is integrating embedded systems and indoor localization in industrial automation. I am Rohina Chawla and I'll be moderating today's session. A few points before we begin. We will share a recording of the webinar with you all to revisit at your convenience and share ahead. Also, we recommend that you use headphones for a better experience. Lastly, if you have any questions or clarifications during the session, please park them in the Q&A window and we shall take them up at the end. To give you a brief overview of the webinar, in today's session, we will focus on the latest advancements in industrial automation, exploring solutions like modern embedded systems, cloud integration, and indoor localization techniques, emphasizing their transformative impact on industrial processes. Our in-house experts will share valuable insights on integrating drones and AGVs for precise indoor navigation and leveraging cloud solutions for real-time monitoring. Additionally, they will delve into Amantia's hardware and software engineering capabilities in the industrial automation domain. The session will also feature recorded demonstrations of drone orchestration and mechanical analytics showcased by Amantia's in-house innovations. Joining us to share the insights and take us through the demonstrations are Amantia's domain experts, Rohit Soni and 𝗞𝗲𝗍 𝗧cie. I will quickly introduce them before we begin the session. Rohit is the Senior Technical Manager, Hardware at Amantia and oversees the end-to-end design and development of the company's hardware engineering projects. 𝗞𝗏𝗍 is the Senior Solution Architect at Amantia and an expert in developing firmware and Linux-based embedded systems. So without further delay, I will now hand over the floor to Rohit.
Hi everyone. So this is Rohit joining in from Amantia Technologies, Gurgaon location. So today we're gonna discuss some of the topics, not even discuss. Today's webinar topic is actually around the embedded systems, how we can utilize the services being provided by Amantia and regarding them. So let's begin. All right. Before I completely talk about the embedded solutions, let's talk about the company overview, what we are, what we do, and what all we can do. So we are a 600 plus engineers company, and we have the locations, I mean the offices in US, Canada, as well as India. So India is our basically headquarters where all the design engineers sit. We also have good relations with the ODM partners, and we develop a good ecosystems with all of them. If you talk about the solutions and all, we have multiple solutions. I will be talking about few of them. We have the robotic solutions in which we do some sort of orchestrations and all. We have the indoor localization based solutions in which you can create an indoor map based out of it. We have certain edge applications. Edge applications means developing some sort of hardware or software based applications on the edge platform. For example, the drone with analytics running on its onboard. We also have a good handhold with the 5G developments. We have a Astra 5G named private 5G development solution. Typically, we have our own RAN core as well as CU and DU. So, and regarding next, so design and development, we take care of the industrial and the mechanical designs. This typically includes the design requirement from the customers, where a customer requires a particular product. We can design the outer case. We can work closely with them for their requirements. We also work on the PCB design, whether it's a hardware, I mean, whether it's an schematic or it's a PCB layout. We design end-to-end board layouts and all. On the top of it, to fulfill the customer's end-to-end requirement, we also write the firmware on that board, whether it's a test firmware or whether it's a production firmware, we do it all together. If you talk about the services, definitely embedded is our bread and butter. So we take care of all of the things over here. We also provide solutions regarding the software and the applications, whether the application is based off iPhone or Android, it's a mobile app or it's a web app. We completely support with that. We have a good engineering team for the DevOps, and definitely we do the cloud development as well. We also have, since typically nowadays there is much requirement for the AIML kind of thing. So we also take care of AIML requirements from customer to customer, and then put some sort of data analytics on that part. In short, our domain expertise is, first of all, the industrial automation, which includes the whole embedded part of it. Then the telecom, whether it's a 4G or a 5G or NB-IoT requirement, we fulfill that. We also have a strong handholding and a good customer base for automotive and enterprise use cases. As discussed before, we're going to talk about the hardware and the software capabilities, what Amantia can offer. And then we also have some sort of use cases out of it. So let's start. For the embedded hardware design capabilities. So this particular slide going to talk about the embedded hardware capabilities, how we do it and what we can do it. Regarding the hardware design and engineering electrical layout, we do it end to end. If the customer has some sort of schematics, we take the schematics and then design the layout. If the customer has a particular requirement of the product and he wants us to design the schematics and all, we do it that way as well. So it also includes the hardware board design, PCB CAD designs and all. Onto the firmware, I think Vikas can take care of it.
Hi all. So on the firmware side, Amantia take care of both the Linux-based embedded systems or bareboard embedded systems. In that, in the case of Linux-based systems, we take care of both BSP porting, driver development, middleware and firmware development, also the OS bring up. And on the bareboard firmware, we have expertise in the DSP, so other microcontrollers based on 64-bit, 32-bit, 8-bit, or 16-bit. So that is our capabilities.
Thanks, Vikas, for describing the firmware and the embedded requirements. So coming back to the industrial and the mechanical design, as I said earlier, we totally present a complete package to the customer, whether it's a mechanical industrial case or whether it's a production friendly case. We designed it from end to end. This definitely includes some sort of industrial design first. This means a visual design. And then onto the second phase, we provide some sort of internal references, how the PCB will fit or how all of the internal components inside will look like. Then onto the second part, we provide detailing and the prototype part of it. On the first, we go it for a 3D printed case or whether it's a hand mold type of thing. And then finally, for the production type of thing, we can definitely go with the mold options as well. For validation and compliance, definitely this is a most required thing from the customers, because everyone wants his design to be accurate and verified. So we also provide services for the electrical verifications. For example, if your design is okay or not, it's usable into the production, what are its temperature ratings, will a component fail after some time or like that. We also do the design validation part of it, whether it's a DRC rule check, SI, PI, PDN, etc. Regarding the accuracies and all, we also check the fitments into the mechanical design. For example, if the PCB is able to fit into the mechanical case or not. And then finally, the compliance test. Compliance test also includes the UL and FCC part of it, because most of the US based customers require these type of compliances. Coming back to the prototype and the mass manufacturing, the good part about Amantia is we typically believe in quick prototyping capabilities, and that's what we can actually get a good hold of the project as well. So we quickly design a PCB and all for the ED samples and then do the prototype of it, and then later on refine that complete design for the mass production and then accelerate it towards the market. This is not the limitation. We also provide the after sales support to the customer. For example, if you can check below, we built some sort of BLE asset tracker for one of the Japanese based ODM customer, and they also required the after sales support. So what we did is we tied up with some of the service channel partners in India as well as overseas, and then guided them how to repair this product and what all things you need to check. So they were also equipped with some sort of stock replacements under the warranty, and then make it as quick as possible. So we also provide support on that part. As you can see, these are some of the images which we tried sharing over here regarding the devices. The first one is the connected camera. This connected camera was a 5G based device and then streaming it directly onto the server. This definitely can be used as a surveillance one, or maybe some sort of if we just change the form factor to the body cam, this can be utilized with the police personals and then implement some sort of AI ML part of it to detect if the person is carrying arms or his postures, etc. The second part is the connected smart light module. This was a LoRa based smart light control channel. The good part here is everything was designed end to end here in Amantia, whether it's a power supply, whether it's a module, whether it's a firmware, whether it's a server. So everything was designed. The main capabilities of this module was time based light controls. You can also detect some sort of failures regarding the luminaires. For example, if the luminaire is having much of the power consumption, I mean the current consumption, then definitely we can shut it down so as to avoid further damages. Whether the power factor is not good, whether the voltage, input voltage is not good, those whole parts can be implemented into this PCB and then can be monitored from the dashboard. The second one was LTE based OBD dongle. Nowadays, since there is a requirement for the connected cards, so that particular module was built for one of the US based customer where they wanted some sort of tracking for their own cards. So it was taking the vital parameters from the canvas of the card, that is OBD port, and then relaying it directly to the server. It also equipped some sort of accelerometer and the gyros just to have the driving patterns and movement kind of thing. BLES tracker was basically a lost and found type tracker. So there were two models, the keychain as well as the wallet version. Imagine you carried some sort of keys and you forgot at a public place. So what to do? So you can connect it always from the Bluetooth and then ring the keys. That was the main functionality of this one. It also included some sort of crowd-based GPS technology where if you left and someone other has a tracking app installed in his phone, so this will take the GPS location of that phone and then upload it to the server so the user can be notified that, hey, you lost your keys on that location. The next is energy monitoring module. We definitely work with some sort of ODMs where they have to utilize their energy modules to manage their whole power supplies and all. And finally, it was an IoT gateway. IoT gateway was BLE and Wi-Fi enabled gateway. I think there is one of the use case where we're gonna discuss in further for this one. There are some sort of use cases which we wanted to discuss in this webinar, and some of them, for example, are industrial automation and sector, and then the next one will be the mechanical analysis and all. So let's talk about that. Nowadays, drone is the key requirement for many of the persons. For example, even if you talk about some sort of government people here in India, they also require the drone for the surveillance part of it, and also requires some sort of vital parameters coming back from the drone. So what we did is we designed a 5G based drone which can be controlled remotely, and this particular drone can define its own path. For example, if there is certain obstacles and like that, it can reroute from that path and then utilize it. This the beauty of this drone is it can also be used indoors. See, if you talk about the outdoor drones, they are particularly localized using the GPS only. So if you talk about the indoors, then the GPS signals are not available. Either you use the vision or you use the LiDAR. Vision is not really very good in dark environments, so we opted for the LiDAR version. LiDAR can precisely detect the obstacles around it and then localize it. So we created a 5G network between the Mac and the drone. So Mac is particularly the brain of the whole solution. We implemented the ROS, which is a direct communication between the drone as well as the Mac platform. We implemented some sort of AIs. The AI part of it typically runs on the drone itself, where the obstacle and everything can be avoided. So just in case if the communication between the drone and the Mac server is disconnected, then the drone can take it over. And finally, to monitor all of the things, we implemented a GUI. This is running on the backend side of the Mac. So if you talk about the drone, drones can typically navigate on three axes, that is X, Y, and Z. Drones are really good for air surveillance and all, but we can also talk about the AGVs who can deliver the material from ground to ground. So that's why we also designed one of the AGV based use case. So AGV can navigate in X and Y direction only, and it's more or less the functionalities are really the same as the drone. So it's still a 5G based network topology, and the communication is 5G over the Mac and the AGV. It also includes a ROST based package. So imagine you have a AGV from a different vendor and you wanted to integrate with this particular platform. So we also have some sort of solutions where you just need to populate one of the edge device onto the AGV, and then this AGV can directly communicate with the server and make a ROS bridge out of it. So we also support the cross functionalities of these AGVs. We also implemented AI. For example, the AGV is running low of the battery, so it can automatically reroute its path towards the nearest charger and then dock itself. So we also implemented some sort of stereo camera, a part of LiDAR. So just in case if the LiDAR is not available for any of the reason, we utilize the stereo camera to navigate and then plan its path. And then finally, it's a GUI based solution to control and monitor all of the things. We also support inventory based management. So imagine you have multiple AGVs in your own field, and then you wanted to control all of them via a single dashboard. So we support that. All right. So see, we discussed about the two use cases initially, that is the drone as well as the AGV. So how we implemented it, we're gonna give you some sort of glimpse over that part. So this whole process is known as orchestration. So orchestration is basically an unsupervised way to control or streamline the whole task. And a single dashboard can control multiple vendors and multiple sites out of it, since everything is related to the 5G. So if you enable it through the cloud, then multiple vendors, multiple sites, and everything can be controlled from a single dashboard. We also do the real-time analytics and reporting part of it. For example, what was the behavior of the AGV or the UAV? What was the wind speed? What was the battery at that time? We also make a history out of it, and then a report can be generated from that part. Just in case if one of the AGV has failed, so we also support onto the dashboard. We also support automatic resource allocation and then its task management. What happen if there is some sort of emergency case? For example, there is an obstacle in front of the AGV, so it has to emergency stop. So we also plan its own path, just in case if the obstacle is stationary, then we move out of it, or if the object is moving, then we hold it for a moment or two till the object passes. See, we talked about the cloud management, but this whole solution can also be controlled from a private 5G connectivity. For example, if you don't want your valuable data to get onto the cloud and then have some sort of data or security breaches. So we also support that, since we already have a Astra 5G based solution, so that can be enabled. And finally, as I discussed earlier, we also support multiple vendors, and that's why we have the edge platforms with us as well. Below is the flow diagram, how we do it. On to the right side, we have the AGVs and the UAVs. These regularly send data to the orchestration platform over the 5G. That is their updated XYZ position. And onto the orchestration platform, we implemented the brain, which computes the current as well as the next position and then sends it back to the UAVs. Since we are using the 5G, so the latency is very, very less, and almost all of the computation is done onto the real time. And then this whole data is presented on a user interface. Let's talk about the power management. Over to you, Vikas.
So at Amantia, we have developed solutions for power management. So in power management, we have solutions that controls the or gives industries microgrid based solutions, so that at microgrid is like a say a small grid which has input power sources from multiple sources, could be renewable sources like solar, wind, could be generators, and as well as the battery-based energy storage and the grid. So the microgrid solutions provide the efficient way to switch between the different sources of energy, so that the industries could bring down their power consumption, say billing, as well as have an efficient use of the power, as well as they can have like overview of what is their actual loads, which is and how they can better utilize the different power distribution among the loads, so that they can achieve an efficient utilization in the while running the factories. So here at our solutions work on which is the controller part mainly that we have developed. So our controller communicates with different protocols for communicating with the devices that actually controls the power, like Modbus RTO, Modbus TCP, and also CAN is one of the protocol that we use for efficiently sending between information between different controllers. And we use IC104 meant for SCADA, and MQTT for cloud-based the monitoring, logging, and control. So in our solutions, we have implemented multiple algorithms based on different clients' requirement. So our algorithms, like I have to mention few of them here. So basically, in terms of peak load management is like during the peak demands. We have say most of the times it's not possible to use have like whole of your power from the grid, because the grid has its cost, and different peak hours have different costing. So it's not feasible to go all power purchase through grid. And also with the grid, there is a limitation how much you can want, that you have to forecast like beforehand. So in that case, the solution is we have like renewable sources of energy as well as the grid. In the daytime, we can use the both renewable sources and the grid and the generators to create enough energy and store in the say in the energy storage system, mostly based on batteries. And in the when we have the load, that is like the, let's say, the night time or the evening time, or when there is the like high load is there, which is not be supported by the grid power. So in that case, those batteries could be discharged, and that could efficiently say allows the power, as well as it efficiently, and it helps in bring down the cost of the power. So this is basically happens during the peak hour load management. Now we have like another algorithm is renewable energy smoothing. So it basically requires like in the daytime there are renewable sources of energy that could be used But the problem is the renewable sources of energy is that with the weather conditions, they used to fluctuate. So to compensate that, we used to have the battery-based energy systems, where we basically store the energy generated through the renewable sources of energy. So in case because of weather conditions, the renewable sources of energy is not available as per our load requirement, in that case, the batteries could be discharged to support those energy requirement. Uh, so as like this, we have others like multiple other algorithms we have implemented. So let me talk about uh, the SCADA and the cloud-based monitoring. So on the SCADA side, we have so I told you, like, we have integrated with our EMS, the SCADA, and over the IC104. And in the SCADA, we can say provide the options for monitoring of the device, multiple devices status, and uh, then a monitoring of the power consumption, as well as logging of the various events and alarms, and also the control of any in case if there is an emergency could be found, then the control is also available over the SCADA. Now, the same thing could be taken care through cloud also. Uh, Nowadays, 5G is available. So with the 5G, it is now required that the control and algorithms could be moved to the cloud, so that those can be controlled remotely and and more efficiently, because the point is that with each EMS, there is a cost also installation. So with the cloud-based solutions, we could reduce the size of the EMS like devices, and all the control operations could take place on the cloud itself, control and monitoring. So that is what it is new in this industry. So we have developed those solutions where we have monitoring the power consumption, uh, monitoring of the devices status, and the events logging, all those in the cloud, and anyone can from remotely can see those events, as well as and the power consumption, and take and decisions based on that for load control, or for forecasting the power, or in case wants to schedule different devices like battery discharge duration, what time the battery discharge should start, what will be the peak hours. So those can be all controlled through cloud, and at present SCADA is also a solution in that. So this is all we have done in power management. So this is like a visual overview of our solution. Here you can see the controller is what we have expertise in developing. So this controller acts as a brain to control the power the power generation, as well as also control the power availability to the load. So the controller, as I mentioned, talks with the devices on Modbus, and controls the devices also over the Modbus. It is communicating to the SCADA, which is control monitoring system over IC104, and there are other new protocols that are coming in, and also to the cloud over MQTT and secure MQTT. And here we have mentioned what all we can achieve over cloud, and what we could doing over SCADA, like event logging, power consumption chart, instrument status. And on the cloud, we have since we have with the tools, there are multiple tools for analytics on the cloud, so we can visualize, as well as do power forecasting based on previous week or month power data. And also we can schedule and plan the power purchases, as well as the when we or what is like a battery discharge time, we can decide based on the battery SOC or based on the load, and alarms can also be trigger alarms, and the events could also be tracked, and logging could be done through cloud also. So this is all we are doing in power management as solutions. So the next slide talks about since it is more to industries and monitoring of the devices inside the in industry. So in factories, we have multiple devices, which are some of them are passive, some are have their own diagnostics, some are say are coming with the say communication communication options, or like MQTT, so they can be connected with the cloud or through Wi-Fi or or through BLE to gateways and then to the cloud. So so there are different devices with different capabilities. The cloud-based control mechanisms that we are talking is the idea is to help the say the factory managers to supervise the devices through the cloud. So here in our solutions, we have integrated different sensors for monitoring the health of the devices in terms of vibration, in terms of their diagnostic data, to capture those diagnostic data and send over to the cloud, and also in terms of like the heat generation, or there's a liquid or the liquid like the level of the liquid. So all those things we capture and put on the and send it over through a gateway to the cloud, and on the cloud we can do various top predictions, like and those predictions could help us to control the or predict the timings of the service of the various machines, as well as they can help us to manage their power consumption, and also the power consumption of the factory altogether. This is and also since we are helping in predicting the wear and tear of the machines, so it will also help to reduce the chances of abrupt shutdown of the machines.
Thanks, Vikas. So, taking this cloud control mechanism further, let's also talk about the solution overview. So, on the top of it, you have the cloud with all of the AI implemented. These cloud can directly communicate with the gateways, or maybe directly communicate with the sensor who are capable of communicating directly. So, the whole from the end device, the whole data is sent to the cloud, which can be either a Zigbee or a Wi-Fi based device, and then the cloud will the gateway will directly relay the data to the cloud. If you talk about the gateway has a block diagram. Onto the center, there is a microcontroller, which is the brain of the gateway. All of the data processing in and out will be done by this one. This gateway can be a battery powered device, and then we can always put it either on a charge or maybe charge it from the solar and all, whatever the customer's requirement is. And then right now we have only considered an RS485 based transceiver. So imagine you have a gateway and then your end devices supports the RS485. So the gateway can relay or take the data from that part, and then some sort of status LEDs onto the side. Onto the end device can also be a mains equipped device. See, the gateway has to be battery powered, because if the end device gets offline, the gateway has to report it to the cloud that the end device communication to the end device is lost. So Onto the end device, we can have multiple sensors, for example, temperature, humidity, or anything like that, or even a relay which can turn on and off the device. I mean the load. Let's also talk about the industry automations. So I think Vikas already covered most of the part. So industry automation is very similar to that part, where you can actually monitor the vital parameters of the machines and all. For example, the vibration of the machine is adequate. What is the temperature of that machine? If you have a cold storage type of thing, so you need to maintain the temperature and humidity part of it. So you can all of them do the management part of it from the cloud. On the left side, there are the sample dashboards. So onto the top, the first image shows that these are the particular sensors which you need. You can turn on and off and monitor from it. The second part is the history, where what was the online time, offline time of the device when it reported back to the server. All of the logs are stored. And the third part is, imagine you have a fleet type solution already installed in your premises. For example, a truck, a delivery truck, you need to monitor its own location. So you visualize the whole location on that dashboard platform only. So the solution overview remains, most of the solution overview remains the same. You have the gateway in between, and then these sensors directly communicating with the gateway, and then on the top of it, the data will be relayed to the cloud. And end device can also directly talk to the cloud if it's a 4G or 5G based gateway, and then has a direct internet access. See, since we are already discussing about the industry options and all, so definitely mechanical analytics is also one of the key aspects for the industry. Uh, Let me share you one of the use case in the past. So what we did is, there was particularly requirement for one of the customer where they had certain industrial motors installed in their factory. They wanted to analyze the vibration patterns on it so that they can analyze, they can get the MTBF and all based requirements from that. So what we did is, we designed a whole solution which will take the vibration data as well as temperature data from the motor, relay it to the gateway. The gateway will collect data from all of the sensors and relay it back to the cloud. So the whole analytics will be done onto the cloud itself. This particular approach can directly prevent the costly downtimes and the equipment failures. Okay, so let's talk about the solution overview here. As discussed earlier, BLE sensor tag is communicating to the gateway. It's taking vital parameters from the motors or any of the machines. Imagine you have a lathe machine, imagine you have a motor or maybe some sort of engine. Just take the data from it and then send it to the BLE plus 4G enabled gateway and then relay it to the cloud. The good part of our BLE sensor tag is, we also implemented some sort of energy harvesting solutions on it. So you don't have to worry about the battery power consumptions and all, and you don't need to recharge it often. So imagine the motor is running for 12 hours a day. So we optimize the power consumption out of it. For example, we wake every 10 minutes or 15 minutes, or we define a certain acceleration threshold onto the sensor itself. And if the particular device cross that threshold, the device gonna wake up and then communicate with the gateway and then send the data periodically. For example, just take the 5-second data out of it and then relay it over to the gateway every 10 seconds. And we implemented the IMU sensors on it. IMU is typically your 9-axis sensors, which includes the accelerometer, magnetometer, as well as the compass. Definitely, compass is not recommended for the mechanical, but this type of device can also be utilized on the other parts, which can, I think the compass can be software disabled. Now we used the piezo sensor to the energy harvesting part of it. So the piezo has certain vibrations out of it. From the vibration, it generates the energy, and then we harvested it to charge the battery. The battery can be anything, either a rechargeable coin cell or a lithium-ion based battery. Onto the right side, we see First of all, we get the raw vibration sensor data out of it, which is directly coming out from the motor. This can have some sort of harmonics as well. So we filter it on the device itself. So the filtration parameters can all be altered wirelessly through the gateway. I mean, basically from the cloud. Once the filtering is done, we send this data directly to the cloud where the FFT mechanism runs on. And finally, we get the peak vibration data out of it. We also tried presenting some sort of solution demos over here. So let's talk about that. All right, so let's talk about the drone. On the top, we tried showing you the orchestration data. This contains the map, as well as on the right side, there is a LiDAR heat map onto it. So let's play this. See, over here, there is a green marker blinking. So basically, this green marker is your current location. And we tried sending the location data every 1 or 2 seconds. So the drone is trying to navigate on that part. So the drone did take off automatically and it's trying to reach its own path. And then once reached at location, the drone is trying to land automatically and then gets disarmed. So you can see the fence stopped spinning. A similar type of demo can also be done onto the mechanical part of it. I mean, the mechanical analytics part of it. So let's try that as well. So what we did is we created a product for some of the customers. For example, whenever you try to do your pollution certificate for the vehicle, they need to get the RPM out of your vehicle and then upload that RPM vehicle in your computer and then check the VOC emissions and all. And then we selected the four-wheeler. On the left side, you can see the tachometer data. So the tachometer is currently at 3000 RPM and similarly the 3000 RPM has achieved onto the device. So this particular device is an idea how to get the RPM out of the mechanical devices and send the data back to an analytic engine. All right, so we are open for question and answers.
Thanks, Rohit and Vikas, for the interesting and insightful discussion and demonstration. We will now take up the questions. Please share them in the Q&A window. Since we have a limited time, so we're going to take up just a couple of questions. Rohit, the first one, maybe you could answer. Do you also work on robotic arms?
Okay, I think Harinder asked this. Hi, Harinder, nice to meet you. Definitely, this is a good question. I think we forgot to mention it into the slide decks. Yes, we work onto the robotic arm platforms as well. So what we did is, you have already seen the AGV concept, right? So right now, the AGV was only for the movement purposes and all. We have also provisioned one of the robotic based arm onto it, which can pick and place the objects, place on its own, and then navigate its own path. So we have already done that. And we also support any of the robotic platforms which are directly based on the ROS.
Right. So the next question that I see is, how does Amantia approach the testing and validation of its embedded systems, AGVs and drones, to ensure optimal performance? Vikas, would you like to take that?
Yeah. So at Amantia, starting from say requirements, we have various testing approaches for the design phase. Basically, for if I say the hardware side, so We start with the component selection. In that we have once we have the design. Yeah. Once like we design, we perform the DRC, that is design rule check through the LTM tool. Then once we have some hardware design ready, then we have the power integration test, and then we also have the signal integrity test. All those things are performed. And on the software side, we do perform multiple testings during the development phase, like the unit testing. Each software component, we perform the unit testing. Then there is an integration testing, like integrating the different modules or integrating the modules with the hardware. Then there will be a system testing, system as a whole meant for go for testing. Then the final before acceptance could be the black box testing, independent validation. So these are different say testing stages. Also, we have we do the certifications through about FCC, EIEMC, all those. We have our various we are working with the various vendors or various authorities for those all those tests, and we have performed those test certification or various products previously.
Okay, we'll come to the next question then. How does Amantia tackle the challenges associated with indoor localization, such as signal interference and environmental obstacles? Rohit, would you like to take that?
Sure, Rohina, I will take that. Okay, so that's a good question. See, we define two use cases. First is the outdoor and the second one is indoor. Definitely for the outdoor part, you have the GPS-based navigation technologies and all that cannot be utilized indoor. And into the indoor side, we have two options, either go for the LiDAR one or go with the vision-based orchestration things and all. So we opted it for the LiDAR-based obstacles, LiDAR-based sensing technology. Because see, this particular thing sends the laser waves and then gets reflected from the obstacles, which is again sensed from the LiDAR. It doesn't require any external light or any external environments like that. And this can work up to 100 meters line of sight. So that's why we selected that.
Right, so I'll just take up one last question. Can you share a case study of a successful deployment of Amantia's AGVs or drones in an industrial environment? I know you've covered a little bit of this during the session itself, Rohit, but could you just elaborate this a bit more for the audience?
Sure. So this particular requirement was based out of a US-based telecom partner. Unfortunately, I cannot name it. There they required this type of solution for FedEx deliveries and all. This was definitely an internal one only. For example, taking a package internally and then delivering it to their another warehouse or into the same premises. So we have done this implementation on that part.
All right. Thanks, Rohit and Vikas, for all the questions, answering all the questions and all for the very interesting session. So most of the questions in the Q&A window have been addressed, though I do see a couple more. We have noted these and will respond to them offline. With this, we come to the end of today's session. Thank you all for joining us. We hope you found the webinar insightful. Feel free to reach out to us at connect@amantiatech.com if you have any further questions or would like more information. The recording obviously will be available soon for your reference. Stay tuned for more updates from Amantia, and we look forward to seeing you all in future webinars. Bye-bye.